Okay, in this class we are going to solve some problems asked in GATE examination. So the first problem is given that suppose M is a 3 by 3 singular matrix. So M is a 3 by 3 singular matrix. Singular matrix means what? Determinant is 0. Singular matrix. And suppose that 2 and 3 are eigenvalues of M. Then what is the maximum number of linearly independent eigenvectors? Then the number of linearly independent, so number of linearly independent eigenvectors of the matrix M cube plus 2M plus I means identity matrix, 3 by 3 identity matrix, that is I3 is equal to dash. So how many linearly independent eigenvectors? So anyway so we know that we don't know the matrix exactly, but we know the eigenvalues of the matrix. There is a theorem that suppose a n by n matrix, all the eigenvalues are distinct, then the corresponding eigenvectors are linearly independent. Okay, so eigenvalues are distinct, the corresponding eigenvectors are linearly independent. That is a standard theorem. So suppose lambda 1, suppose if a general case, okay, suppose lambda 1, lambda 2, etc., lambda n are distinct eigenvalues. Eigenvalues of some matrix A, maybe you can take n by n matrix. Now for each eigenvalue we have a corresponding eigenvector. We can have more eigenvector, but we can pick one eigenvector corresponding to each eigenvalue. Suppose we take V1 is an eigenvector corresponding to lambda 1. I pick some V2 is an eigenvector corresponding to lambda 2 and so on. So Vn is an eigenvector corresponding to lambda n. Now look at this eigenvector set is linearly independent. So if eigenvalues are distinct, the corresponding eigenvectors are linearly independent. So this is a standard theorem. Now it's given that M is a singular matrix. So singular matrix means what? Determinant should be 0. And we know that determinant is nothing but product of the eigenvalues. So here given that determinant is 0, and we know that determinant is nothing but product of the eigenvalues. Product of eigenvalues is determinant. Sum of the eigenvalues is trace. Now you get the product is 0, therefore one of the eigenvalue should be 0. And also given that another eigenvalues are 2 and 3. If you take any 3 by 3 matrix, we have 3 eigenvalues. So therefore we have a 0 is a one eigenvalue now we found, because already we know that 2 and 3 are eigenvalues, but the product is 0, therefore 0 is the one of the eigenvalue. Now we have eigenvalues for M. What are they? 0 to M.
Sir, your voice is breaking, sir.
Okay, 1 minute. Now the eigenvalues of M are 0 to 3. Since the eigenvalues are distinct, therefore the corresponding eigenvectors are linearly independent. But the question is not about the eigenvectors of M, it's about the matrix M cube plus 2M plus I. Okay. Now what is the eigenvector? Once you know the eigenvalues of M, we know the eigenvalues of M cube, just you have to raise the power 3 to the each eigenvalue. Therefore the eigenvalues of M cube are 0, 8 and then 27. Now eigenvalues of 2 times M is nothing, just multiply with 2, therefore 0, 4, 6. Now eigenvalues of the identity matrix is 1, 1, 1. Now the eigenvalues of the matrix M cube plus 2m.
Sir, it's given that determinant of m is equal to 0, sir.
Yeah, that's why 0 is the
are-
eigenvalue. It's given the
Okay,
2
sir.
it is given the 2 and 3 are eigenvalue. We don't know another eigenvalue because totally we have 3 eigenvalue. It is given 2 and 3 are eigenvalue. It is given in the problem, but we don't know what is another one. So the hint is it is singular. That's why since singular, therefore 0 is the one of the eigenvalue. So already given the 2 and 3, but we need 3 eigenvalue. So here the hint is you can find another eigenvalue from this hint singular. Therefore we get 0, 2, 3 is the eigenvalue. Now the eigenvalues of m cube plus 2m plus identity matrix equals to just sum these three numbers term by term. Therefore we get 1 and this is 13, right, and this one is 34. Now here look at this is the eigenvalues of this matrix. Since all the this is also, if you compute this again, you will get a 3 by 3 matrix, okay, because m cube is also 3 by 3, 2 by m is also 3 by 3 matrix, identity matrix is also 3 by 3. So in a 3 by 3 matrix, all the eigenvalues are distinct, therefore the corresponding eigenvectors are linearly independent. So maximum you will get 3 linearly independent eigenvectors. So therefore the number of linearly independent eigenvectors of this vector is 3. We can get 3. Okay. Okay, next we solve another problem from differential equation. Second problem. Suppose is given that y of x is a initial satisfy the initial value problem. If y of x is a solution or satisfies, I directly write the differential equation. Satisfy the differential equation x square plus y times dx equal to x times dy with the initial condition y of 1 equal to 2. So y of x satisfies the initial value problem this. Then question is what is the values of y of 2? Then y of 2 equal to, then y of 2 equal to what? So you have to find the solution first. So you can just multiply inside dx, we get x square dx plus y dx minus, or you can take this is equal to x into dy. Okay. Now you can take this y dx to that side. We have x square dx equal to x dy minus y dx. Now if you divide x square both sides, therefore dx equal to x dy minus y dx by x square. Now the right hand side is of the form u by v, that is d of y by x, right, because you fix the denominator square and then fix denominator and the differentiate this minus all the things. So therefore the right hand side is, therefore we get dx equal to d of y by x. Now if you integrate both sides, we get x equal to, or y by x equal to x plus some constant c. Now using this initial condition, if substitute x equal to 1, we get y of 1 is 2. Therefore using this initial condition, we have to find the value of c. So since y of 1 equal to 2, then from this equation 1 plus c equal to y of 1. Actually y means nothing but y of x, okay. So that is y of 1 by 1. Now y of 1 is nothing but just 2 by 1, that is 2. Therefore c equal to 1. So therefore substitute c value in the equation solution. So we get y equal to x square plus x. This is actually y of x I am writing. So therefore what is y of 2? 2 square 4 plus 2, that is 6. So y of 2 value is 6. So using this initial condition, we have to find the constant specifically. Okay. Now another problem from linear algebra. Suppose we have a linear transformation T. Okay, so T is a function from R4 to R4. Be a linear map, linear transformation, LT. Okay, so what is the function is defined to be T of, if you take any element here, so for example x, y, z, w, if you take any 4 tuple, is going to define x plus z, comma 2x plus y plus 3z, comma 2y plus 2z, comma w. So it's given that this T is a linear transformation. Now question is, what is the rank of T? Then the rank of T is equal to what? So you have to use the rank nullity theorem. So for that you have to find the nullity, dimension of the null space. So what is actually null space or n of a? Simply you can take n of t is nothing but set of all vectors which maps to 0. So that is set of all x comma y comma z comma w in R4 such that t of x y z comma w is should be 0 0 0. So that is null space. We are collecting the vector which maps to 0, that is null space, and we have to find the dimension of this null space. Now so here we have 4 unknowns x, y, z, w, using the condition that we have to reduce the number of unknowns. Now what is this function? The left hand side t of x comma y is nothing but this x plus z, that's equal to 0. Therefore we have our equation x plus z equal to 0, we get one equation. And then second, 2x plus y plus 3z, that also 0. 2y plus 2z also 0. And then w equal to 0. Now using this condition you have to reduce the number of unknowns. Here number of unknowns is 4. Now clearly given that from the last condition w is 0. Okay, so therefore I put the last coordinate 0 always. Okay, now using this x plus z equal to 0, therefore I fix x, then z should be minus x. Now I cancel z, I can write z equal to minus x from this first equation. Now even look at the third one, you can cancel 2, we get y equal to minus z. Okay, but minus z is nothing but x, because x plus z equal to 0. Therefore we can replace y by x. I can replace y by x. Now look at this one. You can check 2x plus x is y is nothing but x plus z is nothing but minus 3 minus x. Therefore we get 0. Therefore no need. Now such that we have only one unknowns, namely x in R. So therefore you can take x outside, you will get the vector 1 1 minus 1 0 such that x in R. So how many this is a space. This space spanned by only one vector, namely 1 1 minus 1 0. Therefore this is the basis for this one. Therefore the dimension or the nullity of the transformation T is 1 by rank nullity theorem. Okay, so by rank nullity theorem we have dimension of the domain is 4 equal to rank, we don't know, we have to find the rank, plus the nullity is 1. Therefore rank is 3. Okay, so therefore rank of this transformation is 3. So whenever they ask about the rank or nullity, you have to use rank nullity theorem. Okay, if you know rank, you can find the nullity. So but you can easily find the nullity. Okay, that is a simple way. So even the question is about the rank, you just find the nullity and then apply the rank nullity theorem, you have to find the rank. Okay, now the next problem from algebra. So I already said I think irreducible means what? When we say a polynomial is said to be irreducible, we cannot factor that polynomial into product of two polynomials. Such a polynomial is called irreducible polynomial. Okay, we cannot factor as a product of two polynomial. Okay, now question is, suppose if we take let C in the Z3 integer modulo 3, it contains 0, 1, 2. Okay, such that for what values of C such that the quotient Z3 of x, the polynomial ring over the coefficients of Z3 by the ideal generated by this polynomial x cube plus C times x plus 1, this quotient ring become filled. Then what is C? For what values of C this quotient is filled? Okay, then C is equal to what? Now there is a theorem in ring theory. I think you don't have a ring theory I think in the syllabus, maybe. Okay, so there is a theorem you studied, maybe. Suppose R by M is filled if and only if M is maximal ideal. Okay, M is maximal ideal. So suppose the ideal is generated by polynomial. Suppose the ideal generated by f of x. Suppose f of x some polynomial. Okay, suppose this ideal is maximal ideal if and only if the polynomial is irreducible polynomial. That f of x should be irreducible. Okay. Now if so, for what values of C this polynomial become irreducible? So irreducible means, suppose the polynomial have a root, then it should be reducible. Okay, because suppose f of x is a polynomial and suppose a is a root, then x minus a should be a factor of the polynomial, provided if a is a root of f of x into some g of x. So whenever the polynomial have a root, that polynomial should be reducible always. Okay, but if a degree 2 or 3 over the field, if the polynomial does not have a root, then should be irreducible. Now look at the polynomial x cube plus cx plus 1. But C we are taking in Z3. So Z3 contains only 3 elements, 0, 1, 2. Therefore, there are 3 possible polynomial. Okay, so if substitute C equal to 0, we get just x cube plus 1. If substitute C equal to 1, you get x cube plus x plus 1. And if C is 2, then we have x cube plus 2x plus 1. Now look at the first polynomial. So do you have if substitute any values among these 3 values, 3 numbers 0 or 1 or 2, if substitute there, do you get any 0? If substitute 0, 0 cube plus 1 is 1, is not 0. Therefore 0 is not a root of the first polynomial. If substitute 1, 1 cube plus 1 is 2, 2 is non-zero. Therefore again 1 is not a root. If substitute 2, 2 cube is 8, 8 plus 1 is 9, but 9 is a multiple of 3, therefore we get 0. So therefore 2 is a root of this polynomial. Therefore we can factor this polynomial as a product of two polynomial. Therefore this is reducible. Okay, therefore C equal to 0 is not a suitable C. Okay, we need irreducible polynomial, that means no root. Now if you look at the second possible, if substitute x equal to 1, 1 plus 1 plus 1, 3, modulo 3 is 0. All multiples of 3 should be 0 in this case. Therefore 1 is a root of this polynomial, therefore this polynomial is also reducible. Therefore C equal to 1 case is also not possible. Now look at the third one. If substitute x equal to 0, we get 1, is not 0. If substitute x equal to 1, you get 4. If you take modulo 3, you get 1, again is not 0. If substitute x equal to 2, you get 8 plus 4 plus 1. If you take, we get 1. If you take, remove all the multiples of 3, you get 13. Okay, 12 are removed, therefore remaining 1, again is non-zero. Therefore none of the elements in the ring is not a root. Therefore if you take C equal to 2, we get irreducible, therefore this ideal makes, therefore C is 2. Anyway, you don't have a ring theory syllabus. Anyway, okay. Anyway, just understand what is the thing. So another problem from linear algebra. Suppose we have a 3 by 3 matrix. So M is a 3 by 3 matrix. Okay. And suppose the eigenvalues are 1, 2, 3. 1, 2 and 3 are eigenvalues of M. Okay. Suppose if I am writing M inverse, because the inverse exists, because the product of the eigenvalues is 1 into 2 into 3, that is 6. 6 is non-zero, therefore determinant is non-zero, therefore inverse exists. We can write M inverse equal to, suppose, M square by alpha minus M minus 11 by alpha times I3. I3 means identity matrix. Okay, for some scalar alpha. Alpha is non-zero. Find alpha. What is the value of alpha? Now we have to, since 1, 2, 3 is are the eigenvalues, therefore x minus 1 should be factor of the characteristic polynomial. Suppose I talk p of x is the characteristic polynomial of this matrix. So x minus 1 into x minus 2 into x minus 3 are the factors, but this is a 3 by 3 matrix, therefore maximum 3 degree. Now what is the polynomial? If just to multiply, we have x square minus 3x plus 2 times x minus 3. So we get x cube minus 3x square plus 2x minus 3x square plus 9x minus 6. So we will get x cube 6, this 3 and 3 we have minus 6x square, and then plus 11x minus 6. So this is a characteristic polynomial. But by Cayley-Hamilton theorem, every polynomial is satisfied its characteristic polynomial. Therefore, P of A should be 0. P of M, here M is the matrix. P of M, if replace x equal to M, that should be 0. So that is, we have M cube minus 6 times M square plus 11 times M minus 6 times identity should be 0. Now take 6i to that side and you can take M outside from first 3 term. Therefore we get M square minus 6M plus 11 times identity. So you cannot write constant alone, you have to write the identity whenever you are involving the operator M's. So if you take the 6 that side, we have 6 times identity. Now since determinant of the matrix is product of the eigenvalues, therefore it should be 6 and this should be non-zero. Since the determinant of M is non-zero, therefore inverse exists, the M inverse exists. Now multiply both sides by M inverse, this M cancel, we have a, and divided by 6 both the side, therefore 1 by 6 times M square minus 6 times M plus 11 times identity equal to M inverse. Now we write M inverse equal to, we get now M inverse equal to M square by 6, 6 cancel, we have M plus 11 by 6 times identity. Therefore clearly alpha is 6, because we get in the given format M inverse equal to M square by alpha minus M minus 11 alpha into identity. Therefore alpha should be 6. Okay, so this type of problem they will ask. So first you have to, once they given the eigenvalue, first you have to form the characteristic polynomial. Is that nothing but x minus that root, and then simplify and then use the Cayley-Hamilton theorem. You can adjust, we can write M inverse equal to. Okay, so this type of problems regularly they will ask from the GATE examination. Okay. Okay, so next you can find look at the power series and what is the radius of convergence of the power series. Already we solved that problem. You take the infimum supremum of this one. So I think this is a 6th problem. So consider the series summation a n z power n equal to 0 to infinity, where this a n is 1 by 3 power n if n is even, and 1 by 5 power n if n is odd. Now the radius of convergence is, what is the radius of convergence of the power series? Of the series is dash equal to. So we know the formula 1 by r equal to the radius of convergence 1 by r equal to actually supremum of modulus of a n power 1 by n. Okay. Now here a n's are 1 by 3n, 1 by 3 power n, 5 power 3n. You can take 1 by n, that n cancel. Therefore, just you are going to take the supremum of only two things. Just 1 by 3 and then 1 by 5. Okay. Since 1 by 3 is the biggest one, therefore supremum should be 1 by 3. Therefore, what is the radius of convergence is 3. 1 by r is 1 by 3, therefore r should be 3. So whenever they give the series like that, but they given a n's like this format. Okay, for even case this is happen, for odd numbers a n is this. Just you have to take the supremum of modulus of a n power 1 by n, that's a 1 by r. Okay. Sometimes some a n's are maybe 0. In that case we have to take the supremum. Don't worry about this one. So just use this formula 1 by r equal to supremum of modulus of a n power 1 by n. Okay, this is very useful formula. Okay, now we move to the next thing. Okay. So, okay, the number of non-isomorphic groups of order 10. Seventh problem. The number of non-isomorphic. We count only non-isomorphic groups. Sometimes two groups are isomorphic. In that case, you have to count only one. Okay, don't count two groups if both are isomorphic. The number of non-isomorphic groups of order 10. So how many non-isomorphic groups are there? So first we have to look about what is the group actually. If we take any group of order 10, what is the properties of that group? So first of all, you have to write the number as a product of prime powers. Given any problem in algebra, if they given related to order, first you have to write the number is a product of prime powers. So but here just 2 into 5. Okay. And we know the theorem, suppose a group of order G is P times Q, where both P and Q are prime numbers, distinct prime numbers. And the first one is, first theorem, suppose P is strictly less than Q and P does not divide Q minus 1. If both P and Q satisfy this property, then G is cyclic. The group should be cyclic group. And second theorem says, suppose P is less than Q, but P divides Q minus 1, then we have only one non-abelian group of order PQ, then unique non-abelian group. Non-abelian group of order PQ. Only one non-abelian group of order PQ but maybe abelian groups are maybe somewhere, maybe you can find so many abelian groups. Okay, now how many we will get? So you will get, so therefore we can split into two cases. Okay, abelian, how many abelian groups you will get, how many non-abelian groups you will get of order 10. Now by this theorem, these 2 primes 2 and 5 satisfy this condition. 2 is less than 5, okay, correct. 2 divides 5 minus 1, 4. Yeah, 4 is a multiple of 2, therefore this is also satisfied. So therefore we have only one non-abelian group. In that counting we have only one. So for non-abelian group we have only one. What about abelian groups? In abelian groups, how many groups of order 10 up to isomorphism? That is, if you both are isomorphic, you cannot count all the things. So here just you have to take the power. Okay, this is power 1, this is power 1. You take the partition of this power 1. So that is partition of 1. So partition means what? How many times or how many different ways we can express that 1. Only one way, namely 1. Therefore the power, you can take the partition into partition of this power, again this is 1. So partition of 1 is 1, again 1, therefore we get only 1. So therefore for abelian groups category we have only one groups up to isomorphic term. By non-abelian groups category we have only one. So totally we have only 2 non-isomorphic groups of order 10. If you take any other groups of order 10, either is isomorphic to this non-abelian group or isomorphic to this abelian group. Okay, so first of all I quickly recall what is mean by partition. Partition of the number. Okay, suppose 4, if we take, or we can take 3. So we can write 3 as 3 and then 2 plus 1, this is another way we can express, or 1 plus 1 plus 1. So we can don't write 1 plus 2, okay, 1 plus 2 same as 2 plus 1, either decreasing order or increasing order. Now we can write only 3 different ways we can write 3, therefore the partition of 3 is 3. Now what is the partition of 4? How many different way we can write 4? 4 we can write 4 and then 3 plus 1 and then 2 plus 2 and then 3 plus 2 plus 1 plus 1 and then 1 plus 1 plus 1 plus 1. So how many ways? Only 5 ways. Okay, so therefore partition of 4 is 5. Similarly we can find the partition of 5. How many ways we can represent 5? So given any natural number, we have another natural number partition of n. So the theorem says in a abelian group, so question is the number of abelian groups. Okay, maybe using this. So note or formula, number of non-isomorphic abelian groups. So this result I am saying only for abelian groups. Number of non-isomorphic abelian groups of order some n, but we know that suppose n is a prime powers like p1 power alpha 1 or okay anything p2 power alpha 2 and so on, some p r power alpha, because any natural number we can write product of prime powers. Suppose the order is right this one, the number of these is the partition of the power alpha 1 into the partition of another power alpha 2, where alpha 1 alpha 2 alpha r are numbers, natural numbers, into partition of alpha r. So if you take the product of this partition of the powers, this is the number of non-isomorphic abelian groups of order n. Okay, so keep in mind it is only for abelian groups, not for all other groups. Okay, now
So then
yes.
then how will we find for non-abelian groups, sir?
No, we don't have any formula for finding the number of non-isomorphic non-abelian groups. Okay, so we have theorem only for abelian groups, number of non-isomorphic abelian groups. This is a formula. Okay, we don't have formula for abelian non-abelian groups. Okay, so therefore these theorems are very important. These two theorems are very important. If group of order PQ, either the PQ is P is less than Q, but P does not have a Q minus 1, the group of order PQ is always cyclic. The second theorem is, suppose P divides Q minus 1, then we have a unique non-abelian group of order PQ. Suppose if you have any other non-abelian group of order PQ, that should be isomorphic to one of these one. Okay, that is an important theorem, so keep in mind. Okay, now we move to the next problem. So this is a very important formula. So first you try to write the given numbers as a product of prime powers. That is a basic fundamental in algebra or number theory. Okay, now the next problem. Suppose A is a 3 by 3 matrix with determinant of A minus I. So I means what? 3 by 3 identity matrix. Suppose the determinant is 0, is given that determinant of A minus I is 0. Suppose if trace of A is 13, trace of the matrix is 13, determinant is 32, and determinant of the matrix A is 32. Okay, now what is the sum? The sum of squares of eigenvalues of A. The sum of squares of eigenvalues of A is what? So can you guess any at least one eigenvalue using the given assumption?
1, sir.
Yeah, 1, because determinant of A minus I is 0. So we know the eigenvalues of A are 1, 1, 1. So anyway you are going to subtract the eigenvalues of A from 1, 1, 1. But we get a product is 0. Therefore at least one eigenvalue of A should be 1. Okay. Now this is so we know what is the thing. Okay, anyway, so we can know the general form of the characteristic polynomial of 3 by 3 matrix. So that is x cube minus trace of A into x square, and then you can raise another way of writing trace of adjoint of the matrix, or I can write some other thing, right? So trace of A square minus trace of A whole square into x minus determinant of the matrix. So this is any 3 by 3 characteristic polynomial. So simply saying, this is sum of the roots, this is a 2 product of the roots, and this is a product of the roots. But the what, suppose assume that lambda 1, lambda 2, lambda 3, maybe we can simply solve, because this 3 by 3 matrix we have only 3 eigenvalues. We can call lambda 1, lambda 2, lambda 3 are eigenvalues of A. Okay, good. But is given that determinant of A minus I should be 0, therefore one of the eigenvalues is 1, right? Without loss of generality, we assume that the first eigenvalue is 1. Because given that determinant of this one is 0, therefore one, or at least one eigenvalue should be 1. So now we can write this one. And is given that trace is 13. Trace is nothing but sum of the eigenvalues. If sum these 3, 1 plus lambda 2 plus lambda 3 should be 13. Therefore, what is lambda 2 plus lambda 3 is 12. We know this. And the product of the eigenvalue should be 32. Therefore, 1 into lambda 2 into lambda 3 is 32. We know this. Actually, what is asking? The sum of squares of eigenvalues. So what is the sum square? 1 square, that is 1, and then lambda 1 square plus lambda 2 square. Actually that is 1 square is nothing but 1. So we have to find out what is the value of this sum. Now you take this, just to square both the side. Therefore lambda 2 plus lambda 3 whole square, and this should be 12 square. What is 12 square? 144. And this is a square, that is lambda square plus 2ab, 2 lambda 3 plus b square, that is lambda 2 square. And we know that the product lambda 2 lambda 3 is 32. 32 into 2 is 64, and then you can take the 62, that's say therefore lambda 2 square plus lambda cube, lambda 3 square should be 144 minus 64. So how much? 80, right? So therefore should be 80. Now substitute here, therefore 1 plus 80, therefore 81. So therefore the sum of squares of eigenvalues should be 81. Therefore answer is 80. Okay. Any doubt in this? Okay. Now the next problem, we can go for next one. That is the initial value problem. We can easily find that one. Already we solved many problems related to that one. Maybe quickly we solve from the differential equation. So 9th question. Suppose we have a second order differential equation y double dash plus 2 times y dash plus 5y equal to 3 times e power minus t. Okay, here independent variable is t, and e power minus t into sin t. Okay, with the initial condition y of 0 is 0. Now and then y, because this is second order differential equation, therefore we need a one more initial condition, derivative y dash of 0 should be 3. Now what is the solution? Y of x. Okay, so the first option y of t equal to e power t times sin t. So from the using the initial condition, we can easily omit some of the options quickly. Okay, if it is solution means it should satisfy the initial condition. So just to substitute t equal to 0, you will get 0 or not. Okay, that is the first thing. You can omit some options. So the third option is y of t equal to 3 times e power t into sin t, and the last option is y of t equal to 3 times e power minus t sin t. Now quickly we can omit some option. You have to check if substitute t equal to 0, that should be 0. But is everything satisfied? Because all the terms contain sin. Okay, sin 0 is always 0. So it's very difficult task. Now one more thing is you got to check this one. Now look at the last option, because this is a very simple function. We can differentiate the last option with respect to t. We get y dash, and 3 is cos term. You can fix. First you have to fix e power minus t, and then differentiate sin, you will get cos t. Plus if you fix sin t, if you differentiate e power minus t, we get minus. That's why I put minus here, e power minus t. Now substitute t equal to 0, that is y dash of 0 is 3 times e power 0 is 1, cos 0 is 1, minus sin 0 is 0, we get 3. Anyway, this the last option satisfied this condition. Now look at the third option. So similarly you can find the derivative for this one, y dash equal to 3 times e power t. So same thing, I think this also satisfied, right? So better you got to find the solution. So we know how to find the solution, right? First you got to write the auxiliary equation, and then you can find the thing, and then you can find it. Okay. So otherwise that is a better way. So sometimes you can directly omit the options using the initial condition. Okay. So that is a better thing. So first you have to write the auxiliary equation of this one. So what is the auxiliary equation? Is m square plus 2m plus 5 equal to 0. Okay. Now what are the roots? Maybe I think you will get complex roots. Okay. So I think m equal to minus 1 plus or minus 2i. Okay. So these are roots. So therefore the roots are complex, therefore the complementary function is c1 times e power minus t, because here t is the independent variable, therefore e power minus t times c1 cos 2t plus c2 sin 2t. Okay. Now you have to find the values of c1 c2 using the initial condition. If substitute t equal to 0, you will get sin 0 0, cos 0 1, and then c1 should be 0, because the left hand side we get 0, right? Therefore you will get c1 is 0. So therefore the y of t function should be e power minus t. I think they are asking only the complementary thing, therefore c2 times sin 2t. You have to find the values of c2. So first you have to differentiate these. Apply UV method. Fix e power t minus t. Differentiate cos sin. We have cos 2t into 2 plus fix sin 2t and then minus e power minus t. Therefore substitute 0, y dash of 0 we know that is given the 3. Therefore this should be c2 times, and this term is always 0 because sin 0 0, cos 0 1. Okay, so we have a 2 times e power 0, that is 1. So we will get, I think I did some mistake, I don't know where I made. Okay, anyway, so I get c2 equal to 3 by 2, right? Okay, so no, I did actually some mistake. So you fix this one. So I think they are asking particular integral maybe. So no, you got to substitute you got to find the value c1 c2 after you write the complementary function plus particular integral. Okay, so now time being don't find the values of c1 c2. So this is just a complementary function, and then you know how to find the particular integral, pi equal to 1 by f of t, all the things. After that you have to find the values of c1 c2. Okay. So maybe I'll do the exercise that is very little lengthy to find the particular integral. Okay, so just to find, after that you write the solution y of t equal to cf plus pi, and then substitute t equal to 0, find c1 c2, and then substitute and then take the derivative. After the substitute 0 equal to 3, you will get a c1 c2. Okay. Okay. So the next problem, maybe you can take some integral value. I think which question, 10 some 10th question. So find the value of the double integral over the region R xy dx dy. Okay, actually what is this R? This R is the first quadrant bounded by the curve. Okay, R is the first quadrant, so the graph should be in the first quadrant bounded by the curves y equal to x square and y plus x equal to 2 and x equal to 0. Then what is the value of this? Okay, so first you draw the picture and then look at the region. and then you have to write the what is the range for x and y. Okay, so this is 0 and this is x-axis. So we have one bound is x equal to 0. Now we have to draw this line y plus x equal to 2. So what is actually y plus x equal to 0? If substitute x equal to 0, we get 2. Okay, therefore this is 2 for x equal to 0. For y equal to 0, we get 2. So suppose I take this is 2. Therefore line joining these 2 points is one curve. Okay, this is 2. This also 2. Now another one is x equal to 0, this line. Now this one is parabola. So parabola is like this, y equal to x square parabola. Now you will get the region this. So this is our region. Now we have to find the okay, what is the range for x and range for y. So therefore x start from 0. Okay, so the starting point for x is 0. If x is 0, y value is 2 anyway. So therefore the integral, double integral over r xy dx dy should be equal to, so the x ranges from 0 maximum, what is the x? So this is the intersection point. Actually this is the maximum point for x. Okay, so we got to solve these two equations. X square is a parabola, this is equal to the line sorry 1, right? So should be 1.
1, 1, sir.
That point is 1, 1. Therefore therefore the x starting from 0 to maximum is go to 1. Okay, now what is the values for y? So what is the values of y? Is start from the curve, is passing through the curve, right? Therefore starting from x square, finally we reach this line. What is the line? Actually y equal to 2 minus x. Okay, therefore starting from x square, below the curve is x square, the curve moves to finally reach the y equal to 2x, that is 2 y equal to 2 minus x, that is the range for y. Now xy, first you have to differentiate with integrate with respect to y, and then differentiate integrate with respect to x. Treat x is a constant, therefore 0 to 1 x y square by 2 x square 2 minus x is the upper limit lower limit into dx. So therefore this is nothing but interval 0 to 1 x into, if substitute the upper limit we can take 2 outside. So 2 minus x whole square minus x square is x power 4 into dx. Now what is that? You can take 1 by 2 outside, interval 0 to 1 x into this is a 4 minus 2ax, that is 4x plus b square, that is plus x square minus x power 4 into dx. Anyway you can multiply this x inside, we have 4x square, 4x cube, 4x power 5. Now directly you can integrate 4x square by 2 cancel, we have a 2x square, and 4 by 3 x cube, x power 4 by 4 minus x power 5 by 5, 0 to 1. So just to take the upper value, so therefore this is equal to 1 by 2 times 2 minus 4 by 3 plus 1 by 4 minus 1 by 5. So that's it, answer. So if you simplify these, finally you get, I think maybe you can directly write 9 by 24. Okay, so I will simply write 3 by 8. So just to try, you will get 3 by 8. So therefore the area under this curve region is 3 by 4, 3 by 8. So first you have to find the region. Once you find the region, you can easily find the thing. Okay, so similar problems are there. Maybe you can take as an exercise for a triple integral. And the next problem, we can move. I think you don't have a operational research. Yeah, similar type of problem from linear algebra. This is 11th problem. Okay, so problem number 11. Okay, suppose we have a 2 by 2 complex matrix. P is a 2 by 2 matrix with the complex entries, and the trace of the matrix is 1. Trace of the matrix P is 1, and the determinant is minus 6. Determinant of the matrix is minus 6. Okay. Now question is, what is the trace of p power 4 minus p power 3? The matrix p power 4, p power 3. What is the trace of this matrix? Since this matrix is invertible because the determinant is minus 6, therefore is non-zero, therefore is invertible. Okay. Now what is the trace? So is a 2 by 2 matrix. If you know the eigenvalues of p, we can easily find the eigenvalues of p power 4, and then you can add the eigenvalues of p cube, then you can easily find it, and just sum the thing. Now what are the eigenvalues of p? Therefore what is the characteristic polynomial? This is a 2 by 2 matrix. Therefore the characteristic polynomial is x square minus trace of a times x, or p, trace of p times x plus determinant of p. So x
So
is,
it must be minus 2.
What is that?
Eigenvalues 3 and minus 2, sir.
Yeah, okay. Now or minus 3 or 2. Sum should be 1. Yeah, correct. Yeah, product, yeah, correct. So 3 and 2. Therefore the eigenvalues of p are, I can take, first you take a negative number, so 2 and 3. So what is the eigenvalues of p cube? Is minus 8, 27. What is the eigenvalues of p power 4? 16, and then 81, right? Now just to subtract. So what is the eigenvalues of p power 4 minus p cube? This minus this, we get 24, and this one is minus, means how much? 81 minus 27, 56, correct?
54, sir.
Yeah, sorry, 54. Thank you. Now this is the eigenvalues of this matrix. Now we are asking the trace. Just to add these two, we get 78. 78 is the trace because sum of the eigenvalues. Okay. So you try to find all the eigenvalues. If you know all the eigenvalues, we can easily find the thing. Okay. The next question from group theory. Suppose the 12th problem. I simply write the problem. Suppose G is a group. The order of the group is 2, 3, 1. Okay. The question is the number of elements of order 11. How many elements of order 11? Number of elements of order 11 in the group G is dash. So first you have to write the given number is a product of prime numbers. So anyway they ask me about the number of elements of order 11. First you have to check the 11 divides 231 or not. So first you got to write the number is a product of prime powers. So what is that? Okay, so 2 3 1 should be, so if you divide by 11, so what you'll get? Maybe we can
21, sir.
21 into 11, right? Again 21 can be written as 3 into 7, 3 into 7 into 11. So this is the prime factor of this number. Okay, now we have to find the number of elements of order 11. So maybe I think you will get only one 11 silo subgroup. So why I am saying that? So we have to find, there is a theorem also you can find that, suppose the group of order product of 3 primes p q r with the condition that p is less than q less than r, then the group contains a group of normal subgroup of order r or normal subgroup like this. Okay, anyway, so first we have to find the number of 11 silo subgroup. So that is a Silo's theorem. So first okay, quickly I discuss about the Silo's theorem and then we come to this problem. So first of all what do you mean by p group? So quickly we can recall the definition. So p is prime, small p is a prime, we say a group is p group if the order of the group should be prime power, p power some n. Okay, so a group order is prime, single prime power, then we say the group is p group. And suppose we say subgroup is p subgroup, a subgroup is said to be p subgroup, the order of the subgroup should be prime power if the order of the subgroup H is p power some m. Okay, where H is a subgroup of G, but we don't know about the order of G, order of G anything, but the subgroup order is prime power, then we say the subgroup is p subgroup. Okay, so the next definition, Silo p subgroup. When we say a subgroup said to be p silo or Silo p subgroup or p Silo subgroup, either they can use Silo p subgroup or p Silo subgroup. If that should be p group, that should be p subgroup, therefore the order of H should be p power some m, but this is the largest power. That means what? P power m divides the order of G, but the next power p power m plus 1 does not divide order of G. Okay, such a order element, such a order subgroup is called p Silo subgroup. That is the maximum prime powers that divides group order. Such a subgroup is called Silo p subgroup. Now the Silo's first theorem says existence of Silo p subgroup in a group is always exist. Okay, so because we can easily find the maximum power. So suppose a 2 divides a group order. Suppose 2 square does not divide order of G, then we can exist 2. 2 is the maximum power. Suppose 2 square also divide, but 2 cube does not divide order of G, then p Silo 2 Silo subgroup exists. The maximum power is 2 square. And so therefore we can go up to, because G is a finite group, we can go anything. So if we have at least one prime divisor of the group G, then definitely that G have a Silo p subgroup. But we don't know how many, but time being we go, there are definitely at least one Silo p subgroup. So that is Silo's first theorem. Silo first theorem. Silo's first theorem says, suppose if you have a group of order, if you take p power some n into some m, but this p does not divide m, because that means what I am saying, this n is the largest power for this p. So simply saying the GCD of p comma m is 1. There is no common divisor for this one. That is simply saying n is the largest power for this p. Then G has a Silo p subgroup. Silo p subgroup. that subgroup order is p power n. The maximum power is the subgroup order. Okay, so that is the Sylow's first theorem. Existence of Sylow's theorem, Sylow subgroup. Now the second theorem says any two subgroup are conjugate. So what do you mean by conjugate? So when we say two subgroup are conjugate, if one subgroup can be written as some C times another subgroup. For example, so simply say H is a one subgroup, H and K is another subgroup, are conjugate. So when we say these two subgroup are conjugate, if we can find a element G in G such that one subgroup can be written as GK G inverse. If you write like this, such a G exists, then H and K are conjugate. So, so the Sylow's second theorem says any two P Sylow subgroup are conjugate. Okay, that is Sylow's second theorem. Sylow's second theorem says if you take any two Sylow P subgroup, any two Sylow P subgroup are conjugate. Conjugate. Okay, that is the second theorem. Now third theorem is the important, is the number of P Sylow subgroup should be of the form 1 plus Kp for some K. Sylow third theorem is a very important theorem, but all the theorems are very important, but the problem maximum asked from the third Sylow's theorem says the number of Sylow P subgroup is of the form this theorem says only the form, not the exact formula. Okay, the number of Sylow P subgroup is of the form 1 plus Kp, 1 plus some K, K is some number, positive number, some P is the prime number. We are talking about the P Sylow subgroup, that prime. So for some K should be greater than or equal to 0. 0 also included, but should be in integer. This is a Sylow's third theorem, and that number should be divides the cardinality of the group. That is the number 1 plus Kp should divide the group order. That is a very, very important thing. Okay. And another thing is there. Suppose if you have only one P Sylow subgroup, that subgroup should be normal. Similarly, suppose a P Sylow subgroup is normal if and only if it is only one. That is very, very important note. Suppose the Sylow P subgroup is normal subgroup is normal if and only if the number of P Sylow subgroup is 1 plus K, right? This number should be 1. Or if you have only one P Sylow subgroup, that subgroup should be normal. Okay. Now come to our problem. We are asking the number of 11 Sylow subgroup. So therefore the number of 11 Sylow subgroup, 11 is a prime number. Sylow P 11 subgroup or 11 Sylow subgroup is, otherwise you can take equal to 1 plus K times 11, okay, or 11K, you can take anything. Is of the form 11 times K. We don't know what is K, but we got to find the K. How to find that k? Using this condition that the theorem says the number should divide the cardinality of the group. So this number should divide group order. But group order we know that 3 into 7 into 11. Now the GCD between these two number, because 11, but this is not 11, this is a multiple of 11, but this number is not a multiple of 11. Therefore GCD of these two numbers is 1. So there is a theorem in number theory. Suppose a number A divides the product of two number B and C. Suppose the GCD of A with one another number, suppose B, GCD of A comma B is 1, then implies that A should divide the remaining number. So this is very important result in number theory. Suppose a number divides the product of two number, and then GCD of A and either C or B is 1, then A should divide the remaining number. So therefore by Ising theorem, this 1 plus 11k GCD of that number and then 11 should be GCD 1, because 11 is a multiple of 11, but this never is a multiple of 11 because we are adding always 1. Okay. So therefore GCD of that two number 1, therefore by theorem that number 1 plus 11k should divide the remaining number. What is the remaining number? 3 into 7, that is 21. Now what are the possible? Since we know that this number 1 plus 11k divides 21, therefore the possible values for this 1 plus 11k, either maybe is 1 is a divisor, or 3, maybe its value is 3 or 7 or 21, because this number is a divisor of this number. Therefore it should be positive, right? This 1 plus 11k is a positive number, but should be 21 means what are the possible? Only either that value is 1 or 3 or 7 or 21. Now for what values of k you will get 3? K should be positive. For any values of k you will not get 3. If k equal to 0 we will get 1. Okay. Again, if you substitute any values of k, you will not get 7. Even if substitute k equal to 1, you get 12. If substitute k equal to 1, you get 1. So therefore you will not get 3 and 7. What about 21? If substitute k equal to 2, we get 23. You will never get 21. Therefore that is also not possible. Therefore only possible is 1. Therefore now we found that the number of 11 Taylor subgroup is only 1. So we call that subgroup is, namely we can call H. What is the cardinality of this H? The maximum power of 11 in the group. So maximum power is 11 because 11 power 1. So this is a prime number. Okay. Now therefore should be cyclic. This subgroup should be cyclic subgroup. And how many generators are there? There are pi of 11 generators. So pi of 11 is a prime number. The pi of 11 is 11 minus 1, 10. So there are 10 generators. For this subgroup H, H is cyclic group. And how many generators we have? We have a 10 generators. And we know the theorem that the generator order should be equal to group order. Okay. If in the cyclic group, suppose G is a cyclic group generated by some element A, then order of the element should be the order of the group. So only this is happen for the generators. Now the theorem says since H is a cyclic group, how many this order is 11, how many generators we have? Pi of 11. So pi of 11 is 10. So there are 10 generators are there for H. All the generators are group order, equal to group order. Group order is 11. So how many elements of order 11? We have a 10 generators. Therefore all the 10 elements are order 11. So therefore now our question is solved is 10, because only one 11 Taylor subgroup, and then order should be 11 power 1, because the group factor, the order of the group factor maximum power is 11, not 11 power 2, 11 power 3, anything. So maximum power is 11. So therefore that subgroup contains 11 elements. Okay. Suppose simply I can take that it should be 11 elements. Since H is a subgroup, therefore should always contains identity element, and then the remaining elements I can take A1, A2, etc. up to A10. So totally 11 elements. And the order is 11, therefore it's a cyclic group, and the theorem says the number of generators is pi of the order, pi of 11. So pi of 11 is 10. So there are 10 generators. Identity elements never generates any non-trivial group. but should be 10. So therefore the remaining 10 elements are generators. And the theorem says the generator order same as the group order. So group order is already we know that 11. Therefore this element order is 11, A2 elements order 11, and 7, A10 order 11 is 10 is 10. So you will get 11 order element only in this subgroup, not for other. Suppose we have a group this is a group G. Now we found that H is the 11 silo subgroup. Now you will get 10 elements of order 11 here. You will not get any element here of order 11. Okay, you will get 11 order element only in the subgroup H, inside H, not outside the H. Therefore already the list that we have only 10 elements of order 11. Okay, anyway we can stop now. Thank you.